things I am moving. Okay.
Yes, sir.
Good morning, everybody. I am V.O. Principal V.O.ChidambaramCollege. I welcome today's resource person, Mr. Stalin Tangapallam, senior member of the technical software from US. In spite of his busy schedule, Sir has accepted our kind invite. So once again, on behalf of our V.O.ChidambaramCollege, I welcome you, sir. I welcome all the participants from the different states of our country. As V.O.ChidambaramCollege has been doing a lot of activities in the COVID-19 for the past 2 months, the entire credit goes to my faculty, both teaching as well as non-teaching. I should tell this fact. Our honorary secretary is a guiding force for all of us to do a lot of things for the welfare of the students community as well as the public. Our professors are doing online classes, webinars, quiz. In addition to that, we the VOCians, we have been doing a lot of social awareness camps through online. I'm very happy to say all of the things to you regarding that VOC is concerned. As far as the VOC college is concerned, we are very prestigious institution in the south skits of Tamil Nadu, because it was established in the year 1951 by Kulabadi APC Veerabahu. We are having almost all UG and PG programs in our institution, and 10 departments have been elevated as a research center. Our professors have been doing a lot of projects funded by UGC, GST, CS, ICAR, DBT, then NECS also. Our college has been identified as one among the nodal center for IISRO Hyderabad. We are having a GIS lab also. Our professor is doing a lot of program for the welfare of the students community using the GIS. We have been tapped a lot of grants from the UGC for the development of our institution. Recently, we got a grant from UGC Hyderabad, a multi-purpose gymnasium, and we are having a more than 10,000 square feet indoor stadium also. Recently, our institution got STRIDE scheme, a Parama scheme. Our college has accredited by NAC. We the VOCian, we are very proud to say that we have retained the A grade continuously for 3 times, 2004, 11 and 17 respectively. This is a small gist as a principal. I am briefing about our institution. So with this word, once again I welcome all the participants, all the members from our own institutions. Thank you. I will pray to God Almighty shower His blessings to all. Thank you. Over to Gomadi Nayakam.
Thank you, sir.
Thank you, sir. Thank you for your motivational welcome speech, sir. Now I request Professor Jude Hema to introduce our resource person. Over to Jude Hema.
Very good morning, everybody. I take the privilege of introducing our resource person, Mr. Stalin Tangapparam, to you. Having completed his engineering graduation in National Institute of Tiruchirappalli, he started his career in EMC Data Storage Systems, Bangalore, as a software developer, and then moved to Dell Technologies, Boston, USA, as technical architect. Currently, he is working as senior member of technical staff at VMware, Boston, USA. He has about 15 years of experience in software industry and in the domain of managing private and hybrid cloud. He has got 4 approved patents. We are really honored to have you amidst us, sir. With these words, I hand over the session to our resource person, Mr. Stalin Thangaparam. Over to you, sir.
Oh, thank you. Thank you, Hema, madam.
Thank you, sir.
It was an excellent introduction. Let me share my screen. Just give me a second. I'm having some
Yes.
trouble in resuming the session.
I think you showed a white screen.
Yeah, I'm trying to stop it, but the cursor is not moving over there.
Oh. And from your side, could you stop that one?
Okay, sir. Yes. Okay, now I have shared my screen. Okay,
No,
now
no.
I stop. இப்போ நான் stop பண்றேன்.
Okay.
Okay, இப்போ I think இப்போ blank screen இருக்கும்.
Do the same again. அது மறுபடி பண்ணுங்க.
Just a second, sir.
Yeah. Okay. Not able to get my cursor.
Open first up. Okay.
Oops. I can't find my cursor. That's the problem. Okay. Hopefully this time it works. Where am I in? Let me leave the meeting and
Okay, sir.
I'll
That's
join
fine.
again.
One second.
Yes, sir.
Okay. Dear participants, sorry for the interruptions. The Department of Computer Science is organizing this meeting. I requested Dr. Ms. Gomadi Nayagam, head of the department, to give a brief note about the Department of Computer Science. Gomadi Nayagam, please.
Yes, sir. Sir, hello, participants. So, V.O.ChidambaramCollege, it was started in the year 1951 under V.O.C. Educational Society. So, our department, it was started in 1998 and PG was started in the year 2004. So, there are 10 faculties in our department. Actually, many in-house softwares were developed by computer science department, library software, office administration software, then examination, right from allotting the examination session to the staff till the seating arrangement. Everything is purely, it's completely software based. So all the credits goes to my beloved faculty members of our department. So library is also completely automated. So we have a barcode system and we are planning to move to RFID system also. So I think, sir, Stalin has come. Sir, make him co-host.
Oh, I'm sorry.
Yeah.
Yes, sir, Stalin, sir.
Are you able to hear me?
Yeah, yes, sir.
Yeah, it just says host disabled attendee screen sharing.
Okay. Now I do it.
Yeah.
Sir, now try, sir. Now you are become a
Yes.
co-host.
Yeah, I done it.
Yes, sir.
Hopefully this time it works.
Yeah, it's worked, sir. It's come.
Okay, nice. Okay. Hello, everyone. First of all, thank you for inviting me. It's a great opportunity for me. So, in the current software industry, the industry is actually moving towards open source. Um, you know, the older period of having proprietary softwares, it's no more. Nobody is going to own their own softwares. They're publishing in open source, so that they form a community over that, so that individual developers can contribute and make that platform available for everyone. That's where the software industry is moving towards, which really means information is out everywhere. You can just check in Google, you can find things. There's a lot more, but generally the problem here is, who is going to do a head start on those, right? It's always difficult because there are too many things out there, and especially for students, it's really tough to grab certain things unless someone gives a head start. So my intention of this session is going to be a head start to all of you, so that you guys can keep exploring things, uh, which makes you much more efficient. Okay, here is what the contents are going to be. Let's discuss about in the early 90s how the application deployment was, and then um, what happens when virtual machines arrived, and then we'll talk about the current Docker container world, and then we talk about what is there in cloud computing, and finally we'll talk about Kubernetes, which is kind of the cutting edge technology right now, which has the most demand in the market. Okay, let's start with the history, right? In early 90s, what we have is, suppose if you have a banking application to deploy, or what you generally do, you have a server room where you have a list of servers, and then from your home place, if you have a banking application, you would have a fiber channel cable attached to the server room, so that you can retrieve data much faster. Things are working fine, but the problem with that approach is, the banking data is very critical, right? So what happens in data centers, the banking customers especially, they are not ready to share their system, which is holding their software, with other vendors, because it's kind of a security issue for them. They don't have a solution at that point in time. For a shorter period, what they did is, they had to individually allocate servers for the vendors, which means, if you are for an ICICI bank, you have their own set of servers, and then you go with UTI, you have your separate one of servers. This works, but the problem here is efficiency, right? ICICI might have, say, 20 different applications, and then they might have like 30 different servers allocated to them. The efficient rate is very low. When I say efficiency, it's all about how efficient your server resources are being utilized, your RAM, how it is utilized, how your storage is being utilized, how your CPU power is being utilized. Because the resources are shared only with certain smaller number of applications, the resources are not well utilized. And it's not about utilization, it's all about the cost also, right? Because every individual server want to maintain, you have a maintenance cost on top of it. Consider the electricity, consider the data center space, it's too much. So in early 2000s, companies started innovating things. They just wanted to something more simpler, as well as more efficient, as well as more cost cutting, right? That's why they come up with something called virtual machines. Virtual machines are nothing but, you can consider them as a software program which exhibits the behavior of a physical machine. When I say that, you know from outer world, when you look at a virtual machine, you can't differentiate between a virtual machine and a physical machine. They both are the same. So on a particular physical machine, you could create n number of virtual machines. I'll go to that story in the next slide. Right. So on the left hand side, what you see is a host or a machine, right? And then on your machine, you'll have your operating system installed. It could be Windows or Linux, and then that's what you're, and you generally, what you do is you generally deploy applications on top of the operating system, right? Your applications could be banking, airline, could be anything. Things are working this time, but as I said, the problem is the efficiency, electricity cost, data center cost, maintenance cost. It's not going to scale. So what we did is, we created virtual machines on top of the physical machines. So in this diagram, you see there is something called the colored green, red. These are virtual machines. These are independent machines which are running on top of your physical server. We call them as virtual machines. If you look at the diagram, the virtual machines have their own guest operating systems. When I say guest operating system, it's just your actual operating systems. So if you have a Windows machine, it is running on Windows operating system, right? On top of the Windows operating system, you could create virtual machines which can run Linux operating system. You could create virtual machines which can run CentOS operating systems, right? And each virtual machine, even though they are running inside a physical machine, they have an isolation boundary. When I said isolation boundary, it's all about the security aspect. A virtual machine running with CentOS cannot access data from a virtual machine which is running Linux OS, even though they share the same physical machine. This is the most critical part which customer really needs. From a banking standpoint, all they need is security. They don't want their data to be shared across a software which is run by another vendor. That's the whole reason why they moved on to different systems. Right now, with the virtual machine concept, you are still utilizing resources because you are sharing the physical resource. At the same time, you are creating isolation boundaries for the customers. So a Citibank application running on virtual machine 1 is not going to be, cannot access data from a virtual machine which belongs to say ICICI. That's not going to work, right? So they are able to isolate this. And right now, if you look at in data centers, 99.99% of the servers are already virtualized. Nobody's running physical servers. Everything is virtualized out there. And this transition happened from 2000s to I would say in the next 15 years till 2015. Things were running fine. You have virtual machines. They create isolation boundaries. Customers are happy. From from a technology standpoint, when I say virtualization, if you have an operating system like Windows, it doesn't allow you the flexibility to create virtual machines on the fly. So you need a software which runs on your operating system, which should have the flexibility to create virtual machines. That particular software is called hypervisor. In the diagram, you can see on top of host operating system, you install a software called hypervisors. That software has the flexibility to create virtual machines on the fly. So there are different vendors who have created their own hypervisors. Microsoft has come up with something called Microsoft Hypervisor. VMware has come up with something called ESX, which they are the market leaders in virtualization. So there are open source hypervisors too. If you want to try out things, you can always do a Google search on hypervisors. You can find open source hypervisors which you can install on your system, and then you would be able to create different virtual machines on your system itself. And you can have these machines for different purposes. Is there any questions here? Am I going a little fast, or is it okay?
Yes, sir, it's correct, sir.
All right, okay.
Yes, sir. Sir, actually, we have a question and answer session at the last,
right,
towards the end. So I think you can continue, sir.
All right.
Yes.
And now, till 2015s, we have the virtual machines and data center is completely virtualized. Things are fine, and then we started moving towards cloud resources, right? That's when the actual term of cloud came into picture. People started thinking about having a public cloud, have a private cloud. They started with the private cloud. When I said private cloud is all about each, if you look at these enterprise banks, the bigger banks, right? What they do is they own their own data centers. These data centers will be like huge place, huge where there will be a lot of servers, and they call something called storage arrays, which I don't know whether you guys have heard of, but storage arrays are actually a 8-foot container, a typical container box where the box will have huge number of disks. So all they need is like, they're actually a 8-foot box, which their own operating system. On top of that, they manage a set of SATA disks or fiber channel disks, right? And then you have these switches in place. So the switches, the storage arrays, and the host, they all comprise the data centers. So when data is being pushed to the data center, they go through the switch, they go to the host, and then they settle on the storage disks, which are part of the storage array. Things are fine, but still they wanted to achieve some more utilization, right? More than virtual machines. Instead, they wanted to create a self-serviced software-defined portal for their customers. You can take up this example. Just take up Citibank. They're a huge bank, and they already have deployed so many data centers all over the place. And one fine day, they found out, okay, I have, like, say, hundreds of data centers all over the world, and I see that I'm utilizing only 50% of those data centers for my applications. So I need a way really to make money out of the remaining 50%. How can I do that? That's when they started thinking of cloud. uh, Especially they call them as service providers. What they do is they start a service provider business where they tend to rent their resources out. So if you have a server in your data center, it's a physical server, or on top of that you have virtual machines, right? You start thinking of renting these virtual machines to the outer world, so that they can use the time where the virtual machines, whatever time they use for, and then they pay rent for it. That's when the idea of cloud started. So cloud is all about you know uh, providing computing power to people all over the world, without having any access to their physical resources. um, in simple terms, if I'm a user, and say I got an idea of creating a software product, right? I don't have any investment, I don't have a mission, I don't have all the resources I need. What I can do is I can try to rent those resources from someone. When I say resources, it's all about machines, it's all about softwares. That's what the cloud provides. Those service providers, what they did is they created a cloud environment where people can rent through software. So they, through the browsers, they will say that, okay, I need access to 5 virtual machines which say 100 GB capacity, right? I need these virtual machines for a period of, say, 20 days. And then they start using it, and then once that is done, they return back the virtual machines to the service providers. That's how the cloud actual business started. For the cloud to scale, the problem with virtual, so far the virtualization is done only at the virtual machines layer, right? And if you look at the previous diagram, the virtual machines are nothing but a software program which has its own operating system, and on top of the operating system you would be running your applications. So when you start moving towards the cloud, which is actually an Internet of Things business, right, where anybody can access anything anytime, through any device. If, say, I'm asking, say, I need a machine with 500 GB capacity with, say, 20 GB RAM, you should be quick enough to provide that to the end user, because it's through the wire. It's no more a physical business, it's all a virtualized business, right? So you need quicker access. Virtual machines have a baggage, right? They carry a baggage of the operating system. So whenever you wanted to create a virtual machine, it is going to take minutes, because it is going to start up its own operating system, and then on top of that it is going to install whatever is required by you. So that process is not going to scale. So they're trying to move out of virtual machines and come up with some other technology which can ease the process. That's where they come up with something called containers. Containers are nothing but, again, a software program which includes the package. When I say package, the package includes the application code and all its dependencies to run the application. Let's take an example, right? Suppose you wanted to run a Java application. You have created a Java application, and then you wanted to expose the Java application in the cloud so that people can use it. You can think of IRCTC railway system. Right now, it runs on the cloud, right? It's an application. It's a Java application, and you can use it through the browser. Means through the internet, you can use that application. So in order to do that, what they really did is, these they has to be very lightweight, right? You cannot afford to start operating systems every time when a user asked for a resource. That's not affordable. So you need something to be lightweight. So these containers are actually independent entities which can run on its own. When they say run on its own, means it contains the application code and all its dependencies. So from a Java application standpoint, what else you need for a Java program to run independently? You need a Java runtime, and then you need the application code, and then you need the port where your application is exposed to. If you know all these three information, then you'll be able to start the application all by your own, right? Because Java is platform independent, so irrespective of your operating system you run, if you have these three information, the Java code, the Java runtime, and the port where your application is exposed to, you would be able to run that application anywhere in any device. That's the concept which the containers took. So containers are nothing but a software program which packages your code, your dependencies, which are required to run that application. And this is nothing new. If you look at Linux kernel, there is something called C groups and namespaces. When you combine C groups and namespaces, what you can achieve is an isolation within your machine. When I say isolation, it's again the virtual machine concept. You create an isolation boundary within your physical machine itself. That isolation boundary can be represented as a physical machine to the outside world, right? So the same concept they wanted to commercialize. That's where a company called Docker came into the picture. What Docker did is they took this concept of C groups and namespaces, and then they create something called container. They name it as containers. Okay, and that's where container was born, right? These Docker company took the idea of C groups and namespaces and create something called containers. If you look at the diagram on the left hand side, this is different from virtual machines. You have your infrastructure, and then on top you can say infrastructure as your physical machine, right? On the physical machine you have your operating system running. On top of the operating system you are running something called a Docker engine. Docker engine is a software. It's just like hypervisors. For virtual machine you need a hypervisor. For Docker you need a Docker engine interface. A Docker engine is a software. On top of the Docker engine, all those blocks are nothing but applications. If you look at these applications does not hold any operating system on their own. They share the Linux kernel which is underneath them. They don't really depend on the actual they don't really need the operating system, even though they can still be an isolation boundary. If you look at my previous diagram with virtual machines, instead of Docker engine, you have this hypervisors. On top of the hypervisor you would be having virtual machines, but each virtual machine have their own guest operating system. That's the burden which we have in virtual machines. That is the burden which is not letting us to create resources quickly which can be accumulated within the cloud. So the containers have that capability because they don't carry their own operating system. They are very lightweight, and the startup of the application will be in milliseconds because you don't need to have this operating system burden at all. Moreover, there is an advantage called layered file system. I'll talk about that in the next slide. Okay. You need to understand the concept of a layered file system. What happens is, suppose I have a physical machine. On top of the physical machine, my operating system is running. On top of that, I'm running the Docker engine software. And then I have created multiple Docker containers. And all these three, I have created, say, 3 Docker containers. And each Docker container is running a Java application. So there are 3 different Java applications which is running on your machine. So what happens is, for a Java application to run, as I said before, you need a Java runtime, your application code, and the port which your application has to be exposed to. So the Java runtime is going to be common across all the 3 containers because all 3 containers are running Java applications. The Docker has the intelligence of, they built the Docker in such a way that if a resource is being shared, that resource will be part of an image. So you will not install the Java runtime more than once in your Docker infrastructure at all, within your host. So if you look at the diagram on the left-hand side, right, there is an image 1 and there is an image 2. When I say image, you can think of an application. We come from the bottom, right? So the base image. So in order for an image 1 application to run, what you need is, you need the base image, which is Ubuntu. On top of that, you need Java JDK. On top of that, you need an Elasticsearch software. These three are needed, are essential for image 1 and image 2 to run, right? And then for image 2, you need configuration files and environment variables. So what happens is when you are creating the Docker image, as you can see on the left hand side, the Elasticsearch, Java, JDK, and Ubuntu, or there is only one layer out there. Even though there are two images or two applications which record these things, the Docker has the intelligence to create a layered file system where these layered images are being shared across the containers which are running on the same host. This is, a key point, which a key advantage over virtual machines. The time to load all these dependence, if somebody is asking, okay, I need a software application, say, which is a part of image 1, to be rented for 20 days, right? So the cloud service provider is going to start immediately. When he starts it, it's going to be in milliseconds, because it is not going to load the base image Ubuntu, it is not going to load Java JDK, and it's not going to load the Elasticsearch, because it is already out there, which is being used by application 2. So it's going to be lightning fast. That's the idea behind containers. So the layered file system is one of the key advantage, in addition to the lightweight model where we don't carry our own operating system. Okay, and a Docker image is nothing but every application out there, being a Java application or a Golang application, any application, they are converted into something called Docker images. Docker images are runtime images. You could, using the Docker engine, you can run the Docker image. When you run the Docker image, you are actually starting the application. So you can think of an image as a ISO file, right? Just your operating system file. It's just a file. When you start the file, you are actually starting the application. So if on the right hand side, the topmost screenshot is about a Docker file. So those things, actually, it's a Node.js application. If you look at the line 1, it says from node organ. It's nothing but that is the dependency which you have to download. And then you copy the package JSON. That's your location of your source code. And then you are exposing the particular location on the 8080 port. So these three information are needed for this particular Node.js application to run on its own. So this is the Docker file. When you provide this Docker file to the Docker engine, the Docker engine is your interface between the Dockers and your operating system. So when you provide the Docker file to the Docker engine, the Docker engine is going to create a Docker image for you. The image is what you see in blue color, which is bottom, right? Where every command which is specified in the Docker file will be created as an image. So from the bottom, you'd see for every command, you create an image. That's why it's called layered file system. So on the right, on the left hand side also the same thing. So the base image Ubuntu is actually a command in the Docker file. So for each command, you create an image, and you stack this image on top of it, and finally you get a layered image system. And then on top of the layered image, what you have is you have a writable layer. That writable layer is actually accessible to that particular Docker container. In other words, when you're starting a Java application, a Docker application, the Docker on your Java application, suppose if you're writing to the disk, right, you need some space. That particular space is the writable layer in the Docker container. That you can see on the right hand side, there will be a rightmost, it says a writable layer on the top. Okay. So far what we have talked about is, we talked about what do we mean by Docker containers, and how do we create those Docker images, and what is meant by a Docker file, and what is meant by a layered file system. So far, with whatever we have discussed so far, we would be able to create a Docker containers on top of your operating system. So you know uh, you could try this on your own. It's a simple software to download. If you have Windows machine or Linux or Mac, whatever it is, you can there are resources out there where you can try it on your own. You could create different containers on top of your physical machine, and these containers are independent isolated entries. Now there is a question, right? Okay, I have allocated a set of servers to a particular bank, and these servers run that particular customer's applications. because all those applications are part of the customer, they wanted to share data with each other, even though they are different applications. So you are running different containers, but these containers need to talk with each other because they are part of the same customer. So you need a way to actually create networking between these different containers which are running out there. That's where we call it something called there is something called default Docker bridge. So whenever you install the Docker engine on your operating system, it creates something called a Docker bridge. I'm not going to get into detail, but in simple words, if you look at the first diagram here, the outermost box is nothing but your physical machine. On your physical machine, the ETH0 is your Ethernet port. That's where you connect your LAN cable, right? And that Ethernet port is going to give you the IP addresses. So on top of the Ethernet port, on the bottom you have the IP tables. The IP tables are used for routing purpose. And then on the bottom you have the Docker 0. The Docker 0 is the Docker bridge software, which is created by the Docker engine. And then on the bottom you have on top of the Docker bridge, you will have these Dockers containers. So the C1 and C2 are actually the Docker containers which are running. So the Docker containers are exposed, if you look at the port number, it says 8080:80. What it really means is each of the Docker containers, C1 and C2, they are exposed on port 80, but for outside world, they are exposed on port 8080. So if I have hosted this particular machine to outside world, if I wanted to access that application, I would use, I would open my browser, I would type the actual link, and I will say :8080. That particular request will come to the Ethernet port ETH0 of this machine. And in the IP tables, we have already done the routing where if a request comes from 8080, then you have to transfer the request to a Docker container which runs on port 80. That's the mapping which you specify. This particular IP table routing is done by the NAT software. You have to install a NAT software, network address translation software. This is the default simple Docker bridge which you have, which comes up with Docker installation. In more complex environments, in data center environments, what you use is something called a overlay network. A overlay network is what I would say is you have different machines, and then each machine is running a set of containers, right? You can take up this example. You have like 3 different machines, independent machines, and they have their own operating system. On top of their operating system, they are running their own containers, and all these 3 machines are actually a cluster group which belongs to, say, a customer one, right? So the containers which run on all these 3 machines need to share data between each other, which means these containers has to somehow talk with each other. So far the Docker bridge which I talked about is very specific within a particular host. Right now we are going to talk about how we do networking across hosts, right? Because in our case there are 3 different hosts, and we wanted the containers which are running on these 3 different hosts to talk to each other. So what we call something called overlay network. Overlay network are actually virtualized networks which you can create on top of the physical network available. When I say the physical network available, it is your LAN cable, right? You will have a LAN cable to connect all your 3 machines together. That's how physically they talk to each other. What you do is when you connect your LAN cable, each they have their own IP address. That's the physical IP address of the Ethernet port which they belong to. You don't use that IP address. Instead, you create a overlay network, which is a virtual network. You can assign your own subnet IP addresses to it. And then what you do is that particular overlay network will alter the IP tables, and it will say that, okay, the application which runs on the same concept, the application which runs on 8080, if it receives a request on the 8080, with some IP address, in the IP tables, you had already done the routing to transfer that particular traffic to the corresponding container, which may run on any host. That's how things are being done. I will not get in detail into it. This overlay network configuration, this is mandatory for container network to work across hosts, and they call by a term called container network interface. They call it a CNI. And there are multiple open source softwares which are available. They call it something called Flannel, Weave, Calico. These are softwares which create overlay networks on top of your container networking, so that you can provide the ability to for the containers to talk with each other. So again, this is a big subject. I'm trying to go through it so that at least we can get a picture on how these things work. So far we have created Docker containers, we have created Docker file, we have created the Docker runtime, and when you inject the Docker file into the Docker engine, the Docker engine is going to create a Docker image and then start the application. And then if you wanted to if you want the Docker containers running on multiple hosts to talk with each other, you need a overlay network, which you can do using third-party softwares like what I said, like Flannel, Calico, and things like that. So far things are okay. Because containers are lightweight, right? You can start containers in milliseconds time. In a real data center environment, people will be running 10,000s of containers, right? So it's not manually possible for anyone to monitor these things, because these are like highly, if I am an end user, right? I connect to a public cloud, like Amazon cloud, right? And then I'll say that, okay, I need a resource for 5 days. Somebody's going to start a container with whatever I require. So, and it's not possible for a end user to, or for a user to actually go and do things whenever a user is requiring it. It's not possible. So you need an automated system especially for managing the containers. That's where the concept of Kubernetes, or the software called Kubernetes, comes into picture. And this is the most cutting edge technology right now, which is in greater demand, and at least for the next 3 or 4 years you'll have this in demand. So what Kubernetes does is it is a software. Again, it provides you the management layer to manage the containers. So it can automatically create containers, it can automatically delete containers, it can automatically scale up containers. You can think of this way, right? So you have the IRCTC system itself, and assume that you are running the IRCTC system in a container, right? And whenever it is a festival time, people will be like too much. They'll be logging into the system. There are too many people logging into the system. Obviously, if there are too many load, your system hangs. So you need a way to scale up your system. They call it as distributed systems, right? So even the same application will run on multiple machines, but they have a way to coordinate with each other. So this particular scaling, the because it is container based, the Kubernetes has intelligence to start up a container based on the load on which it is running. You can instruct saying that, okay, I'm running this IRCT application as a container in your Kubernetes infrastructure. If the memory or the storage of that resource of that particular container goes beyond 75%, then automatically start a new container with the same application. You can configure things like that. So whenever the load comes up, the Kubernetes has the intelligence to automatically create another application, and then because it's a cluster, it automatically works. So these kind of things, Kubernetes has the capability. You can scale up, you can scale down, you can always create, you can destroy. You have a nice management interface to do all things. This is what gives you the flexibility to create containers much quickly, manage containers much quickly. If you look at the architecture, I'll just go through in a quick way. Kubernetes is again a software, right, which runs on a cluster of machines. When I say cluster of machines, you have 3 independent hosts. You can make them as a cluster. Means they all 3 are working together. That's what it's called. So when you install a Kubernetes software, you can say that, okay, machine 1 is my master, machine 2 and machine 3 are the worker nodes. So in the same diagram, the Kubernetes master is actually running on machine 1. The worker node 1 is machine 2, and worker node 2 is machine 3. All the gray boxes are actually installed by the Kubernetes software itself. Even the blue color ones is the Docker runtimes. It's very simple. The idea is you have a Kubernetes master which gives you a API interface available for outside user. So the outside user can say that, okay, I need to create a container, an application, and this is my location of the Docker image. If I provide that information to Kubernetes cluster, Kubernetes will automatically find the best worker node, and it will instruct the Docker runtime saying that, okay, somebody has given me a request to create an application with this image. go and create it. And he can always say that, okay, he needs to create this application with 5 different instances running, which means 5 different applications of the same instance will run on different machines, just for scalability purpose or availability purpose. You could do it. And then he can configure policies on the cluster saying that, okay, if something goes wrong, make sure that you increase the application count by 2 or 3 more. You could do all these kinds of configurations. How it is achieved? It's just a software which is instructing the Docker engine, which is running on each worker node, and saying that, okay, go and start a Docker container using the image which the user has provided. That's how things work. And in the whole thing, I was talking about Docker images, right? There are publicly available Docker images. The Docker community has stored them in something called Docker Hub. It's just a website. If you go to Docker Hub, you can download all the Docker images. You have Docker images for Postgres, databases, message bus, RabbitMQ, all kinds of technology which are open source available. They have a Docker image. It will just take seconds to install a Postgres database on your system. It's that simple. Maybe after this demo, I'll show you quickly. It's very quick. And okay. So now we started with physical machines, then we moved on to virtual machines, then we moved on to containers. We did all this for moving into the cloud environments. That's our actual goal, right? So we need some technology which we can utilize to make our cloud computing much faster. And that's where we are right now. So we are in the era of cloud computing where everything is done via software basis. So there are 3 different services which are provided by cloud computing. These are the main core services: infrastructure as a service, platform as a service, software as a service. Infrastructure as a service is, say if I'm a college grad, right, and I got an idea with my friends, I'm thinking, okay, let me start writing a computer program which can do this certain thing, or you can say that, okay, let me write a program which can track the amount of COVID cases in my city, right? That's an application. You have the idea, how to write the code, but you don't have the infrastructure. You don't have a laptop, you don't have the resource needed for that, you don't have the capability to scale things. You don't need to worry about anything. There is something called the cloud, which provides, is called infrastructure as a service, right? So you ask the cloud saying that, okay, I need clusters of, say, 10 machines, each having a capacity of 500 GB and this much RAM and these resources for a period of this much days, right? And then when you ask that, the infrastructure service, what it is going to do is it is going to use Kubernetes in the backend to create a set of containers on different hosts. So if you're asking for 10 different machines, it is going to create 10 different containers, right? And then it's going to give you access via the container networking, which is talking about the overlay network, right? So from an outer world, for me, I would be accessing that particular machines on an IP address, and I have everything on place. So I can start writing my code. I can do whatever I want with those machines. I have the infrastructure ready. Now I have the infrastructure in place. Next is, in order for writing any application, you need a platform. When I say platform, in software industry, right? Whenever you are writing a code, it's not just about writing code. It's about maintaining the code. It's about make sure that that particular code is not breaking any other different stuffs. So all these are platform things. So in software industry, they have created multiple platforms available for you, which automatically, whenever you commit a code, it automatically takes care of running all the tests, creating Docker images for your new commit, and then applying the Docker image and starting your application, making sure that everything works. Everything is taken care automatically. They call it as platform. Red Hat provides that. EMC provides that. Dell provides that. There are companies which provide this platform as service. Then what you have is a software as a service. Again, in order to build an application, you need softwares like databases, message bus and things like that. And it's not possible for everyone to pay that money, pay the license money and use that in your local machine. Instead, you rent it using the software. Again, when you say I need a Cassandra database for a period of this much, what the software as a service is going to do in the cloud, it is going to instruct the Kubernetes to create a container with the Cassandra image and provide the container access back to you via the networking. That's what it's going to do. So these three steps are the main key for cloud computing, and cloud computing is internally using Kubernetes kinds of mechanisms to create containers in the background. Okay, and then I think we talked about public. We talked. Maybe I'll cover a little about public, private, and hybrid clouds. Public clouds are nothing but Amazon, GK, Google's. Google Clouds, Amazon is there, Windows Azure is there. These are public clouds where anybody can access infrastructure, anybody can access platform, anybody can access software. All these three keys are available out there. These are for all the end users. It's not private. These are for all. Even I can use it. If I have a Google account, I can directly log into Google's cloud and I can ask them to rent probably 10 virtual machines or 10 containers or 10 applications. I can do. Then there is something called private cloud. Customers, enterprise banks like Citibank, they have their physical data centers already. They wanted to convert that into a cloud so that they can provide resources to their end users. And it's very contained. End user like myself cannot have access to that private cloud. It's a very specific security data. Those are like, especially the bankings, airlines, they maintain their own private cloud. Hybrid cloud is kind of a term where you think of a banking application itself, right? If say there is too much data which has to be archived, these data probably will be 25-year-old old transaction data, but they cannot delete those data. They still need to track it, but they don't want to track in their private data centers, in their private cloud, because in the private cloud, they have all the disks which are much costlier. So they are not going to use that for archiving purpose. So what they do is some amount of this data, which they think that can be shared in the public cloud because they are like from archival purpose, they migrate that data into the public cloud, just like into Amazon cloud or Google cloud. So that's called a hybrid cloud. So your data will be migrated between a private cloud and a public cloud. Based on the situation, they will migrate either back from public cloud into your private cloud or from private cloud to public cloud. That depends on the use case. And VMware is playing a vital role here. If you look at in the second slide, is talking about virtualization, right? So 99.99% of the private data centers are already virtualized. So they have built infrastructure on top of virtual machines. Right now, if you move that they wanted to migrate their archiving data, which is on top of virtual machine, onto the public cloud. But the public cloud does not have the virtualized infrastructure. They create their own proprietary technology. Amazon has their own proprietary technology to build their Amazon cloud. So what happens is you cannot blindly migrate a virtual machine infrastructure from a private cloud back into a public cloud. It's not possible. So what VMware is trying to do is VMware is trying to work with these public cloud vendors like Google, Amazon, and Microsoft, and trying to create infrastructure over there, a VM infrastructure, so that the VM infrastructure on the private cloud can be easily migrated to the VM infrastructure on the public cloud. That's where VMware is trying to move towards, which they are getting much traction there. Okay, so far I think we covered almost all the topics. We covered about virtual machines, Dockers, networking, Kubernetes. These are the main I would say cutting edge technologies which are out there, and there are a lot more demand, especially in India, because these are rising technologies which are kind of very new to the market. I have put up resources here which you can go, and the third one is very important. If you guys are interested, if you have a Gmail account, you could get 1 year free subscription on the Google Cloud. It's very simple. You log into, there's something called Google Kubernetes Engine. It's a website. You just log into that, and then you provide your Gmail account. You get 1 year subscription, and there are online tutorials where you can create your Kubernetes clusters, where you can run your containers. You can do things. You can. It's 1 year free subscription. And the book which I have here is very good. If you really want to know about Dockers and Kubernetes, it's really good, and you can always reach me. I'm more than happy to help you with whatever I can. I think we can move on to question sessions.
Yes, sir. Participants, the question answer session is open now. Please, you can raise your hands. I can unmute you and you can ask your audio questions. Sir, actually in chat box, I have got a question, sir.
Okay.
What is the minimum system requirement to run a virtual machine?
On top of my head, I don't have the data, but it's available out there. You can go and figure it out.
Oh, fine. Okay, sir. Say about Docker image and how it works. You said about each command one Docker. I cannot understand the question, sir.
Okay, all
Dr.
right.
Jai
I
Ruby.
think, okay,
Yeah.
I understand. So, okay. So on the rightmost top, right, what you have is a Docker file. A Docker file again is actually an independent entity where you have your code, on all its dependencies. So in this case, it is running a Node.js app. So you're downloading a Node.js software, which is the from Node organ is a Node.js software. When the Docker engine is executing this first line, it is going to create an image. That's where on the bottom you can see it's an image for Node.js, and that image is a base image. On top of that, you will be having an image for your code, your application code. On top of that, you'll be having image for your dependencies. That's how it's been layered. If I'm running a second container, a same Node.js container on the same machine, that will also require node organ software, but the Docker has the intelligence to not download that, rather it uses it. That's why it calls a layered file system. Did I answer the question?
Yes, sir. Sir, what is the difference between CYG Win terminal and Dockers?
It's a little different here, because Docker's CIG Win is very specific about isolation boundaries. But Docker provides, that's the more key point. Docker provides you isolation boundaries within your Linux kernel.
Okay. Yes. Jude Hema.
So
Yes,
another question from Dr. Rajalakshmi. Does IRPCC depend on Kuber architecture? Otherwise, what type it is supported?
I'm sorry, I didn't get the question.
Does IRTCZ depend on Kuber architecture? If not, otherwise what it is supported by? This is the question she has raised, sir.
Okay, the IRCTC application, if it is, see, I just took IRCT as an example, right? In reality, it could be run by Kubernetes clusters, or it could run as a virtual machine on top of virtual machine. I don't know. I just took IRCT as an example, right? So any application, you can deploy an application either on top of a virtual machine, or you can deploy an application as a container. Right now in cloud computing world, people are moving towards deploying an application on top of a container. That's where the industry is moving towards. And the reason being, whatever I explained, it's lightweight. It doesn't have the baggage as virtual machines, and it's easy to, it starts up in milliseconds and things like that.
Hema, any more questions?
No, sir, that's it.
Okay. Participants, if you have questions, you can raise your hands. Yes, it's from Jai Ruby. Jai Ruby, I have asked you to unmute. You can unmute yourself and you can ask your question. Dr. Jai Ruby, you unmute yourself and you can ask your question. I think she is not. Yes, sir. Yes, ma'am.
Actually, I've asked the question regarding the Docker image. Already he had answered. Actually, how I had a doubt that for each, I thought that for each command, Docker image would be created, and over that it is working like that. And after that, he said about all the things. So I got the explanation for that.
Thank you, ma'am. Thank you very much.
He had already answered. Okay, thank you. Thanks.
Okay. Any more questions? Hema?
Yes,
any
sir?
more questions is there in chat box?
No more questions, sir.
Okay, then we can move on to the next phase.
Okay. Thank you so much, sir. Stalin, sir, your presentation was very useful and very informative, and we have received many comments, positive comments from the participants too. Your
Thank you.
crystal clear, so that when he queries doesn't raise up, I think. Thank you very much for sparing your valuable time with us and sharing your knowledge with us, sir. Thank you so
My
much.
pleasure. My pleasure. Thank you.
May I now
Hopefully it is
request-
useful. Thank you.
Yes, sir, of course. May I now request Professor Gomadhi Nayagam, Head and Assistant Professor of Department of Computer Science, to deliver the vote of thanks.
Thank you, Durkema. Good morning to all. Ladies and gentlemen, I deem it a great honor and privilege to propose the vote of thanks on this memorable occasion. Let me first of all start by giving the glory to the Almighty God for making this today's session a resounding success. First and foremost, we are grateful to our Honorable Secretary, Shri APC Chakkalingam, sir, for his words and of encouragement. His able guidance always encouraged us. My heartfelt thanks to our beloved principal, Dr. C. Veerababu, sir, for his stewardship, vision, and commitment. His motivation and unstinted support always encourage us in all our efforts and help us to reap success. Thank you so much, sir. My sincere thanks to our director, Dr. Nele Murugan, sir, for his continuous support in all our efforts. Thank you so much, sir. I thank our resource person, Mr. Stalin Thangaparam, sir, senior member of technical staff, VMR Boston, USA, who despite his busy schedule, has found time to grace this occasion. Actually, we are seeing the time behind your behind yourself, sir. There's a clock behind you. So thank you very much. It's almost nearing 1, I think, 12:30, I think, sir.
Yeah, 12:30.
Yes. Thank you very much, sir, for your interesting and valuable information.
Yeah, my pleasure.
My sincere thanks to our IQAC coordinator, Dr. John Prince Soundaranayagam, sir, for his technical support to conduct this webinar a grand success. Thank you very much, sir. I owe special gratitude to Professor Jude Hema and Professor Ayyadurai Selvaraj, who have worked to ensure that this occasion becomes a memorable one. I also thank my beloved friend Balaji, who has arranged this webinar and make this a memorable day. My heartfelt gratitude to my fellow colleagues for their valuable contribution, guidance, and encouragement from all quarters. Last but not least, I thank all the participants present here who have accepted our invitation and make this function a grand success. So once again, I thank you all for your kind attention. Thank you one and all. Over to him. So, starting, sir.
Yeah.
Thank you, sir. Thank you very much.
Yeah, thank you. I'm dropping off. Thank you. Thank you.
Okay,
Bye.
sir. Thank you. Thank you, sir.
Yeah, bye.
Prince, sir.
Jen.
Sir, thank you very much.
Thank you, Jen. Thank you.
Thank you, sir.
Thank you, sir.
Thank you, sir. Sir, Nele Murugan, sir.
Nice.
Sir, thank you.
Okay.
Sir, எப்படி சார் இருந்துச்சு இது
Super, Jen.
சூப்பர் அழகா டெலிவரி செம்ம டெலிவரி
அவர் பிரசன்டேஷன் வெரி பியூட்டிஃபுல். அவர் அழகா பேசினாரு. ரொம்ப நல்லா இருந்தது. எனக்கே புரியுதுன்னு வைங்களேன். I can able to do Docker.
கண்டிப்பா சார்.
Physics virtual machines நான் நிறைய யூஸ் பண்ணிருக்கேன் ஜிஎன்.
சார் நானும் யூஸ் பண்ணிருக்கேன் சார். ஆக்சுவலா எத்திக்கல் ஹேக்கிங்காக.
ஆமா.
எத்திக்கல் ஹேக்கிங் படிக்கும்போது
பழைய அதுமே நால ஒரு 4 இயர்ஸ்க்கு முன்னாடி ஒரு 4 மிஷின்ஸ் ஓடும் வெர்ச்சுவல் மிஷின்ஸ் நெட்வொர்க்கிங் படிக்கிறதுக்கு. அதுல ஐயத்ரா சார் என்ன பேப்பர் வேல்யூஷன்ல இருக்காரு போல இருக்க.
ஐயத்ரா சார்
ஆடியோ இல்ல.
வந்துச்சு.
அடுத்து எப்ப ப்ரொசீட் பண்ணலாம்
சார்? 6th 6ஆம் தேதி சார். 6th அன்னைக்கு சார் we have a international webinar on 6th.
இல்ல அடுத்த ஷெட்யூல் என்னைக்கெல்லாம் ஃப்ரீயா இருக்குன்னு சொல்லுங்க, அன்னைக்கெல்லாம் ஏற்பாடு பண்ணிடுவோம்.
ஓகே சார்.
இது கரெக்ட். 15க்கு மேல க்ளோசிங்.
ஆமா 18க்கு மேல 18th வரைக்கும் ஃபுல் சார்.
18க்கு மேலயா?
ஆமா 18th வரைக்கும் ஃபுல்.
சரி
18க்கு மேல நான் ஏற்பாடு பண்ணுங்க. ஆமா வச்சுக்கலாம் சார். ஓகே சார்.
Okay, thank you.
Thank you, sir. See, participants, we have